side of 2.5 notes. We spent a little bit of time on Friday, talking about standard form, zeros, and x-intercepts. Okay, we spent some time writing those polynomial functions, and that was putting everything into factors and writing it all out, yes? And so now we're kind of going the opposite direction. They're giving us an equation. We're going to take that equation, and our job is to factor it out. Now, first things first, guys, there's a typo on this problem. I found it as I was working through the answer key. There's a typo. You guys do not have the plus 5x squared on your paper. So you need to include that in. Trust me, I don't have it on mine either. I had to insert it up above. Okay, so just be aware, it's not there. My apologies. I was frustrated. So I redid this page. I redid it for future years, but you guys just have to write it. Okay, so find all zeros of this function and write in its factorization. So basically, we're trying to factor this out, write it in factored form. Now, when we talk about finding all zeros, how many zeros are we going to be looking at here? We are looking at 5 zeros because this is an x to the 5th equation. Okay? Now, we're going to start with, I'm trying to think when, okay, so we did this back in lesson 2.4, part 2. We're going to start by looking for our PRRs. Remember finding PRRs? Yes. So how do we find PRRs? Okay. So this sounds familiar then. Factors of 8 over factors of 1. So what are factors of 8?
1, 2, 4, 8.
Okay, so plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, all over factors of 1, which are plus or minus 1. Now, you can write those out if you want, but they all go over 1, so you can pretty much tell what our options are, aren't they? Okay, what have we normally been doing after we get our PRs? We're going to look and see what the graph suggests. And this is where I found that this is the problem I've used before in notes, but this is where I found my mistake typing it in, that I left off the 5x squared because I wasn't getting any nice neat zeros. So and keep in mind, we used Desmos Sum in Algebra 2 last year. If you're trying to graph something at home and you don't want to use the graphing calculator app, you don't have a graphing calculator by your side, graph in Desmos. That would give you what you need to see here as well. So if I switch over my screen, doesn't it? You guys see several that'll work? Okay, assuming I typed it in right, there's what mine looks like. Well, at least one thumbs up. Okay. What's the graph suggesting that we try then?
8, 2, 1.
Now you have 2, 1, and 4. Are they all part of my potential rational roots list?
Yes.
They are. Okay. So they're part of this list, which is a good thing. They are x-intercepts in my graph. Okay, so now when we say try them, what are we doing? Synthetic division. And this is where you have to go through the synthetic division here because I'm supposed to have how many total zeros? 5. I only see 3. What's that mean about the other 2? They're imaginary. Okay, so this is why the synthetic division is so important. So you can start with whichever one you want. We're going to go through all three. So I grab the -2. Put your list of numbers. It is 1, -3, -5, 5, -6, 8. Synthetic division. Drop the 1. Multiply. Add -3 and -2. Multiply. Wait, am I okay?
There you go.
Okay, multiply. -2 times -5. Add -5 plus 10. Multiply. -2 times 5. Add 5 plus -10. Multiply. -2 times -5. Add -6 plus 10. And multiply. -2 times 4. -8. And add. And you have the 0. We should still have 0 every time, yes? Okay, so this confirms, never a doubt, but this confirms that -2 works, yes? Now what?
1.
Now we've got to try another one, yes? So if I use 1, now what's the key? Yeah, use the answer to your previous problem, because we're trying to factor this down so we can find our two imaginaries. Okay? So, 1, -5, 5, -5, and 4. Okay. Drop 1, multiply. 1 times 1 is 1. Add -5 plus 1, -4. Multiply. 1 times -4, -4. Add 5 plus -4, 1. Multiply. 1 times 1, 1. Add -5 plus 1 is -4. Multiply. And we get a remainder of 0 again. Again, we didn't really expect it not to work, but the whole point of doing this is we need to factor it down. Repeat again, yes? We had 3 zeros, so repeating one more time. This time I'm going to use 4. And I'm using 1, -4, 1, -4. Each time my row of numbers is getting a little shorter that I'm dividing into, right? Okay, drop the 1, multiply. -4 and 4 is 0. 4 times 0 is 0. 1 plus 0 is 1. Multiply, and 0. Okay. As expected, all 3 zeros worked. The graph was pretty, evident on that. What is this 1, 0, 1?
Is it plus minus I squared root of 1?
I'm not ready to talk answer quite yet. You're a step ahead of me.
X to the second
Never mind.
plus 1.
Can we agree that this is x squared plus 1?
Yeah.
And this goes all the way back to the beginning, yes? This was x to the 5th, which makes this x to the 4th. That makes this one x to the 3rd. Or just count from the back, right? Remainder, constant, x term, x squared. Okay, so x squared, 0x, and 1. So take x squared plus 1, set equal to 0. In order to solve this, we're going to subtract 1. X squared equals -1. And
Square root.
square root. What is the square root of -1 in this scenario?
Plus minus I squared root.
Or how about just plus or minus I? Because what is the square root of 1? The square root of 1 is 1, right?
Oopsie.
So it's just plus or minus I.
Would it be wrong if I put 1?
If you put, what, I square root of 1?
Yeah.
It's equivalent.
But it's not what you're looking for.
It's not what I'm looking for.
Alright.
I'm hopeful I don't have to decide if it's wrong.
I'm willing to erase the square root.
I would appreciate that. Okay. What was our job here? Find all zeros and write in its linear factorization. Okay. We have 5 zeros here. We have 5 zeros. If I'm writing it in linear factorization, that means I'm writing 5 factors. Okay. If I go in order here, not that it matters, but -2 gives me the factor of x plus 2. 1 gives me a factor of x minus 1. 4 gives me a factor of x minus 4. I gives me a factor of x minus I. Negative I gives me a factor of x plus I. And that's why we need our synthetic division to do this, guys. Because you can't really factor an x to the 5th. You can't factor it into the imaginary pieces. So, okay, guys. So when the graph is nice and it gives us a couple, use those to get it factored down, and then solve whatever you have left. Okay? Questions on that one? Okay. One more example then. The complex number z equals 1 minus 2i is a 0 of f of x. Find the remaining zeros and write f of x in its linear factorization. Huh? Mm-hmm. Okay. Now, the complex number 1 minus 2i, whoops, 1 minus 2i is a 0 of f of x. How many total zeros am I expecting? Okay, this is an x to the 4th equation. So in the end, I am expecting 4 zeros when I get done. What do I know right now? We know 1 minus 2i. Do we know another one?
We do.
Yeah.
1 plus 2.
Okay, remember complex conjugate zero theorem, I think it's something like that, whatever it's called.
Sure.
Back on page 1.
Yeah.
Okay, that complex conjugate theorem. If 1 minus 2i is a 0, then we also know the conjugate 1 plus 2i is a 0. So that's that complex conjugate zero theorem. That if they give you one imaginary 0, its conjugate is also. So right now I know 1 minus 2i, and I know 1 plus 2i, and that means I have to find 2 more. Yes? Okay. So, yes, it is synthetic division. What's the first one I'm going to use? One minus 2i is a 0, yes? Okay. Can we use synthetic division with that?
Sure.
We can.
You're taking up the tiniest amount of space, so is this really long?
There's a lot of work I have on this one. Okay. There's what is Stetson trying to see my paper?
That's fine.
I have a lot of work. Okay. Now, let me time out and pause for a moment. I didn't have you graph this. Did anyone graph it? Okay.
Should I?
You can, but it's a waste of time.
Okay.
Because you're not going to find any real zeros. Okay? All 4 are complex or imaginary zeros. Or in those words, fake. Okay. Now, as we write this out, folks, I am, and I was asking about spacing here, I am going to leave a little bit of space in between my numbers here. Okay? Yeah. Okay. First number here that goes is 4. What goes after a 4?
0.
Because there's an x cubed missing, yes?
Mhm.
What goes after 0? 17. After 17 is 14 and then 65. Okay. First step in synthetic division is to drop the 4. Next step is to multiply. What is 4 times 1 minus 2i?
4 minus 2i.
4 minus 8i.
Yep.
Four minus 8i basically think distributive property, yes? If you're doing 1 minus 2i times 4, 4 times 1, 4 times 1 minus 2i. Then we're going to add 0 plus 4 minus 8i.
4 minus 8i.
4 minus 8i. And now we're going to multiply. What am I multiplying?
4 minus 8.
You can't look at Katie's face because she's over here shaking her head. And
You have to
Yeah, just
spoil.
you're multiplying 1 minus 2i times 4 minus 8i. It is a whole bunch of distributing, or yes, it is FOIL. Now, I have room down here. I'm going to use it. I'm not going to try and do this in my head, at least not with you guys. So I'm going to multiply 1 minus 2i times 4 minus 8i. Let's FOIL. 1 times 4 is 4. 1 times minus 8i is minus 8i. Negative 2i times 4, minus 8i. Negative 2i times negative 8i is plus 16i squared. You're just kind of right. Clean this up.
Negative 12 minus 69.
I agree. Are you guys with his negative 12 minus 69? I'm seeing some processing going on. Where'd negative 12 come from?
The plus 16 I squared.
We don't leave an I squared, right? I squared is equivalent to negative 1. And so this right here is 16 times negative 1, or in other words, negative 16. I know, it's been a weekend. We've slept since we last did this. I told you, lots of room, yeah. Okay. So, and then obviously negative 8i minus 8i, they didn't cancel, did they? So it's negative 16i. Okay, so where is this negative 12 minus 16i going?
Under the 17.
Okay. This is why I said kind of space your numbers apart, yes? Because we're putting 2 digits in a 1-digit spot. Okay, now we're going to add. We're adding 17 and negative 12 minus 16i.
5.
5
Minus
minus
16.
16.
Good. You're adding like terms, yes? 17 and negative 12 are constants. So 17 plus negative 12 is 5. Carry down the negative 69. Now what?
Distribute.
Do it again.
We get to multiply again.
Bless you.
This time, it's 1 minus 2i times 5 minus 16i. So I'm going to FOIL. 1 times 5 is 5. 1 times minus 16i, minus 16i. Negative 2i times 5, negative 10i. Negative 2i times minus 16i, plus 32i squared. Then we're going to clean it up. What do you end up with?
This was just terrible. 26. Negative 26 and minus 27. What? Oh. Yeah. I will do that.
I'm flip-flopping it,
Sorry.
but the pieces are there. 5 plus 32i squared. So 5 minus 32 is negative 27. Negative 6i and negative 16i, negative 10i is negative 26i. Where am I taking negative 27 minus 26i?
Under the
It's under the 14.
there's no way this is gonna
Does it just equal
be okay.
negative 65 at the end?
Of course. So we need these pieces to do our next part. So we have to keep going. Okay, add 14 plus negative 27 minus 26i.
Negative 13 minus
Okay. So 14 and negative 27 is minus 13, and then carry down the minus 26i. And then
distribute.
we got to FOIL again. It's our final FOIL of the problem, okay? I can give you that, and
Yeah, but then we have to do it again.
Yeah, then we have to do that.
the next problem will work out nicer, actually, though. I know it's hard to believe, but the second go around of this is not nearly as ugly. So I'm multiplying 1 minus 2i. I wrote down the wrong thing. Times negative 13 minus 26i, correct? Oof, okay. 1 times negative 13. 1 times negative 26i. Negative 2i times negative 13. Negative 2i times negative 26i. So I have negative 13 minus 26i plus 26i plus 52i squared.
Negative 65.
Because you did the math or because you're just guessing?
Because I know.
Okay. Minus 26i plus 26i did cancel, yes? Okay. Which all along they haven't been canceling. Thank you. But they did finally cancel here. Negative 13, it becomes minus 52, which does end up being negative 65. Put that up under 65, and we add and we get 0, which was the plan, right? That's what we needed to happen. They told us that was a 0, so all that tells me is I didn't make any mistakes. Now, that was using 1 minus 2i. Now what?
1 plus
1 plus 2i. What are we going to use with this 1 plus 2i?
our do it, please.
Okay, we're going to use our answer from the previous row, okay? And we have to do that to be able to get to our final 2 answers. It is a necessity. So, next to my 1 plus 2i, I'm going to have 4.
Oh, this is a lot easier.
4 minus 8i. 5 minus 16i. Negative 13 minus 26i. Are you finding that I wasn't lying, that we don't have any more foiling to do? Okay. So, same deal. Drop the 4. Multiply. 4 times 1 plus 2i.
4 plus 8.
4 plus 8i.
0.
What is 4 minus 8i plus 4 plus 8i?
0.
Not just 0.
0. I.
How about 8?
Huh?
4 plus 4 is 8.
Yeah.
The reals are still there. The imaginaries cancel. Unless I made a mistake.
No, you're right.
You guys are making me question myself here. And my answer key agrees. Okay, so the reals, 4 plus 4 is 8. The imaginaries, negative 8i plus 8i cancel. So now we're just multiplying by a constant again, aren't we? So now, 8 times 1 plus 2i is 8 plus 16i when you distribute there, right?
Yeah.
Add. 5 and 8 is 13 minus 16i plus 16i are going to cancel. Multiply. 1 plus 2i times 13.
13 plus 26.
13 plus 26i. Now what happens when you add these?
4x squared plus 8. Oh, 0.
You get 0 here. Okay? And somehow all of our i's just disappeared, and we have something we can work with now, yes? What does 483 represent?
4x squared.
Plus 8x plus 14 equals 0.
Okay. Our remaining factor is 4x squared plus 8x plus 13. We need to set it equal to 0. We still have 2 more zeros to find. But now we have a quadratic equation we can work with. Options for finding these other 2 imaginary zeros. Because remember I said if you graph them on the calculator, you can't see anything. Huh?
Quadratic formula.
You have to do quadratic formula at this point. Or I guess there's completing the square. But quadratic formula is going to be your best bet. This is not going to factor. Try product of AC, try slip and slide all you want. It's not going to factor. Because the other 2 zeros are imaginary. Emma, you were trying, weren't you? You were hoping it worked. Okay, so with that in mind, quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Sound familiar? Negative 8 plus or minus, okay, I know 8 squared is 64, I got that much. I don't know what 4 times 13 is.
52. Oops. Would it be negative 208?
Mm-hmm. So that's 208 there. So then you're doing 64 minus 208.
144.
It is. Nice. All over 8. Keep going. Now, is it a surprise there's a negative under the radical? No, because that's going to give me the imaginary, right? That's what, again, we're expecting it, so don't be surprised. Negative 8 plus or minus. What do you know about the square root of negative 144?
12.
Well,
Square root of 144 is 12. The square root of a negative makes it I. All over 8. We have to express this as linear factors, right? Yeah, we're going for linear factorization here. So I can't really leave it in this form. Okay. What is negative 8 over 8? Negative 1 plus or minus 12i over 8. Or in other words, 12 over 8 and then the I afterwards. What do you know about 12 over 8?
6 and
Keep going.
3 over
3 over 2.
Oh,
12, both divide by 4 if you go for the largest. Or if you take the long way, 6 over 4 and then 3 over 2, however you get there. So negative 1 plus or minus 3 halves I. Okay, guys. We got those 2. We have the one we were given, and we have its conjugate. Our job is to write this final answer. Now, I'm going to try and put mine over here. If you've run out of room, go down below, right? You've got the whole rest of the page to use if you need to. Almost forgot. I'm glad I looked at my notes here. Okay. F of x equals. Now, we are factoring this, okay? We found our and we used our zeros to factor. One thing we have to take into consideration, which I forgot to mention to now, and it wasn't an issue on example 4, because if you go back to example 4 and look, we always have to consider our a value back in standard form. And our a value back in standard form here would have just been 1. So I didn't have to carry that down here because multiplying by 1 doesn't change anything, right? What's our a value in this problem? 4. Whatever your a value is, you carry that down as the lead coefficient. Okay, so I'm going to have my 4 down here. Now, we need to write our 4 factors out. Let's go in the order here. Our given was 1 minus 2i. So when we write that as a factor, yes, x minus 1 plus 2i. And so, for those of you that weren't here on Friday, I don't know if you guys have done the front side of the notes yet or not, but what that's doing is that's just saying x minus 1 minus 2i. Okay? And so that's doing x minus 1 minus negative 2i becomes plus 2i. Okay? Next one. Let's use 1 plus 2i now.
X minus 1 minus 2i.
Minus 1 minus 2i, right? That's just doing x minus the 1 plus 2i. Okay. This over here is 2 different ones, yes? This is negative 1 plus 3 halves I and negative 1 minus 3 halves I, yes? Okay. So, x what?
Plus 1
Plus 1.
plus 2i minus 3.
I was doing this one first, so I said minus 3 halves I. Technically, it doesn't matter which one you do first. No. So I did this one right here. I basically said, okay, it's x minus that. And then x minus the other one. X plus 1 plus 3 halves I, right? Okay. Now, one last step. Here's the deal. The answer key's not going to have that answer.
It's what?
Okay. We're not distributing to everything. Here's the deal. The answer key's not going to leave it like this because do we normally have fractions within our factors? Not normally, right? Now, multiplying by 4 out front does not mean it's 4 times each of these factors, because that would be 4 4. So there's just 1 4 there that can be used however we want. What are my denominators here? 2 and 2, which just so happens to be 2 times 2 is 4. So what you would see is they're going to take this 4 and they're going to break it and they're going to multiply it by the parentheses that need it. So they're going to multiply a 2 to the first parenthesis that has a denominator of 2 and the other parenthesis that has a denominator of 2. That means your first 2 parentheses are going to stay as is. So if we write out what our official final answer is, f of x equals, the 4 is gone, right? Because we're going to multiply it 2 2's. We're still going to have x minus 1 plus 2i. I'm still going to have x minus 1 minus 2i. Now, this parenthesis that has a 2, I'm not multiplying just the fraction by 2, am I? You have to multiply the entire factor by 2. So this x plus 1 minus 3 halves I, multiply each of those terms by 2. So that's going to become 2x plus 2. No. My brain is doing 3 over 2 times 2. It's times 2 over 1, so the 2's will cancel and you just have the 3. Okay? And multiply the other factor by 2. 2x plus 2 plus 3i. Okay? That's going to be the final answer to the answer key you're going to see. Okay? You know what? If you can get it up until the step before, more power to you. Okay? Let me help you get it split up if you need to. But based on the way I have it circled in my notes, I probably take either or to an extent. So, okay. Okay. You have some work time. Use it.